Today's lesson is going to be about scale and scale factor. So let's just look at some definitions. Scale is going to be the relationship between an actual object's dimensions and the model's dimensions. So if you've ever worked on building a scale model of a car or an airplane, or if you've ever had, your parents have had a house built and they've got blueprints, those are all scales. So there's a relationship between the actual measurement and the model of the measurement. And they scale it up or they scale it down depending on which way you want those, the drawing to go or the model to go. And a scale factor is how you changed that original to the new model. So sometimes you can take something that's small and make it larger, or sometimes you can take something larger and make it smaller. So the scale factor is how you changed that from the original to the new one. And we're going to use proportions to figure these things out. So the first thing we're going to look at here is the dimensions of this scale, this model between a real building and a model of that building. And the dimensions are proportional because all of the side lengths on this original to the model change the same way. So the length, width, height were all changed using the same scale factor. And so we can use proportions to figure out any kind of missing side lengths or dimensions. So this should look familiar. These things right here should look familiar. These are just two different ways to write a ratio. And remember, there are 3 ways to write a ratio. You just did that on your quiz you took. One is with as a fraction, and the other 2 ways are with the word to or with that colon there in the middle. So we're going to change, or we're going to use the information that we know about ratios to transfer this into a proportion or into a fraction. So the scale factor is 1 to 0.02 inches. Because we're moving from larger to smaller, the scale is actually going to cut that large dimension down because, you have to make it smaller so you can fit it on your kitchen table or whatever. So basically what this is saying is for every foot on the real or the actual building, you get 2/100ths of an inch on the model that you're building. So that's going to be something that shrinks down. So we can use that information to find missing measurements. So we got that because we're looking at this. So let's just look at this scale here for a second. So I'm going to take that 100 feet to 2 inches, and I'm going to write it like this. So basically, because I'm moving this way, I'm going to take this top number to 1. If I was moving this way, that would be different. But the way they're written matters. So I'm going to take this 100 foot. I'm going to take this 100 foot. So for every 100 feet, I don't care about the 100 feet. I want to know 1 foot. Well, what did I do to get that? I divided it by 100, which means I have to divide the bottom by 100 because we're just creating equal fractions. And so that's where I get that 0.02. So basically a scale factor is finding out a unit rate for however many for each one I changed down to the next. So we'll look at scale factor a little more, but the scale factor on this one is just taking that the way we moved, which was from actual down to model, and taking it down to 1 unit of measure. So let's take what we know here. Let's say we've got, here's that ratio, we've got 100 feet to 2 inches. And so if I had 325 feet, I want to know how many inches I have on the original down here, or the new one, excuse me. So I'm going to set up a proportion because I know that for every 100 feet, I actually have 2 inches. So I have 320 feet. How many inches do I have? I'm going to cross multiply that 325 times 2, and I'm going to divide it by 100. So I should have 6.5 inches on the model. So this is going to be reduced down to the scale, and then I'm going to use the actual ratio in my proportion. So let's do it again here. So now in Strawberry Point, Iowa, there's a sculpture of a strawberry that's 15 feet tall. And so actually the scale of this model is for every 3 inches on the strawberry, there are 30 feet on the statue. So the scale factor is moving from 3 inches to 30 feet. So let's just kind of look at scale factor first. So I don't care how many feet 3 inches is. I want to know how many each inch is. So what did I do? I divided it by 3. And so for every inch on the strawberry, I have 10 feet on the statue. So your scale factor is determined by the way that you move. So this matters. It's moving from small to large, right? So the way it's written definitely does matter. So then it wants to know some other information. So it's saying I've got 3 inches to 30 feet, so I can use that. 3 inches to 30 feet. And then I want to know how tall the actual strawberry is, but I know the sculpture is 15 feet. Well, I'm going to put it across from the 30 because this is the statue and this is the actual strawberry. So when you think about the way a ratio is written, the relationship is between actual and statue. So that same relationship has to flow here on the other side. So I'm looking for how tall the actual strawberry is if I know that my statue is 15 feet. So I'm going to cross multiply divide. I've got 3 times 15, so that's going to be 45. And then I'm going to divide that by 30. And I end up with 4.5 inches. Did I do that right? Hold on, I'm just going to check here for a second. 3 times 15 divided by 30. It's 1.5. I didn't think that sounded right. So it's the actual strawberry is 1.5 inches. So the scale is basically taking it down to a unit, the way that it flows, and then you can use that information versus actual and statue. So let's do it again here. We have a Boeing 747, and the scale that we used is 5 meters to 2 centimeters. So in other words, for every 5 meters on the real plane, I have 2 centimeters on the model. So what's my scale factor? This is how it flows. So that's how I'm going to do it. For every 5 meters, I have 2 centimeters. That means for every 1 meter, how many centimeters do I have? So I'm going to cross multiply 2 times 1 divided by 5, and I'm going to get 0.4 centimeters. So this is my scale. So for every 1 meter, I have 0.4 centimeters. I could use that, but I'm going to go ahead and use this part right here. So 5 meters is 2 centimeters. So this is my actual, and this is my model. And so if the wingspan on the actual is 68 meters, I want to know how wide the model is. So remember, if it's actual to model, I have to have actual to model. So the relationship this way is between the actual and the model, and the relationship this way is actual to actual. So let's do some cross multiply divide. So I have 68 times 2 divided by 5. So I end up with 27.2 centimeters. So the relationships still work the same way in the proportion. So again, the relationship is between the actual in the model, and that has to hold true on both sides of that proportion. You can also use this scale, can be applied to maps. I know maps are kind of a long gone thing because we all have phones now with Google Maps on it, but it is kind of a good thing to know how to read a map. So obviously you have to take this huge big state or country or whatever it is you're working with and shrink it down. And so what they do is they give you a scale and tell you. So like right here, this is 20 miles. And so you could apply that to all the other, roads, like this is 20 miles, here's another 20 miles, that kind of thing. So let's just take a look. Josie wanted to travel from her hometown in Wapo, Wisconsin to Chicago. The towns are 140 centimeters apart on the map, and that's important. The scale is 1.5 centimeters equals 2 miles. So this should look familiar. It's one of the ways to write a ratio. So I'm just going to transfer that right down here. And it wants to know how far will Josie have to drive to make it to Chicago. Well, if I'm looking at map to actual, then over here I need to have map to actual. So they have to flow the same way top to bottom on both sides. So if it's 1.5 centimeters on the map, it's also 140 centimeters on the map. So how many miles is that? So this is that relationship that we've been looking at for a couple of days now in proportions and how they work. They should flow the same on both sides because they're equal fractions. So I'm going to cross multiply 2 times 140, and I'm going to divide it by 1.5. And they are 180, and I'm just going to round it up 7 miles apart. So again, map to actual, map to actual. This is your scale. So here we have another map. So scale is 1/4 inch equals 20 miles. So scale and scale factor are a little different. We're not dealing with scale factor right now, so I'm not concerned with what did I multiply 1/4 inch with to get to 20 miles. That scale factor. The scale is actually what am I using? I'm actually going to use that 1/4 inch on my map to 20 miles on my actual. So then I know if it's 2 inches on the map, so that has to go across over here because it's map over actual. How far is it from Montgomery to Atlanta? So now we're going to cross multiply, divide. So I have 40 divided by 1/4. So they're actually 160 miles apart. So again, with proportions, the relationship you have to keep in mind is this way. How is it flowing top to bottom? It has to be consistent on both sides. So it's like dollars over gallons on one side, dollars over gallons on the other. Map over actual on one side, map over actual on the other. So now let's just look at this. St. Paul and Minneapolis are called twin cities because they are so close together and built around the Mississippi, St. Croix, and Minnesota River. They are 7.5 miles apart in real life, but here's the scale they used to draw the map. They used 1.2 miles equals 2 centimeters. So it doesn't really matter which way you go, as again, long as you're consistent on both sides. So I want to know how far they would be on a map, but I'm giving you how many miles they are apart in real life. So this is map, and this is actual, which means 7.5 miles has to go across because it's actual. Actual across from actual, map across from map. And then I'm going to go ahead and do that 2 times 7.5, and I'm going to divide it by 1.2. 12.5 centimeters apart on the map. So then let's look at here the scale factor. It's flowing this way. So I have 1.2 miles over 2 centimeters. Now I don't care about 1.2 miles. I want to know each. mile. So basically scale factor is the way it's flowing, taking it down to that individual unit. So that means I had to divide this by 1.2. So I'm going to have to divide this by 1.2. So 2 divided by 1.2, and I get 1 point. I'm just going to round it up, centimeters. So for every mile on the real road, I have 1.7 centimeters on the map. So when you're doing these, just think about how you write your proportions. Remember, a ratio can have the word 2 in between or the colon. They translate straight into that fraction. If I go model to actual on one side, I have to go model to actual on the other. And the way it's written matters for scale factor. So the way that it flows, this has to be the 1 unit because that's the way it flows. And then you're going to find this out. How did it change? So what's the multiplier between that 1 unit and how it changed?